So back in geometry, the arc length was, your central angle, which we're right here, 360 times 2 pi r was your arc length. Okay? Now what we're changing this into, instead of using degrees, we're going to use everything in radians. So what they're talking about now is, here's what I want you to think of. 2 goes into 360 how many times? 180. Thank you. That was a long pause there. I was waiting for calculators to be open. I was getting frightened. So this is the same thing as angle over 180 times pi times the radius, right? Isn't angle over 180, isn't that the same thing as saying theta over 180? Remember when we were doing that? And theta was your angle measurement. So theta over 180, or the angle over 180, is now turned into radians. Remember, theta, that was radians. And that was your angle divided by 180 times pi. So all we're doing now is converting this part, instead of using degrees, we're converting everything into radians. So it's radians, it's basically your radian measure times the radius is your arc length. So that's why they say that arc length is equal to theta. Remember, theta is the radian measure of your angle times the radius. So the only thing you're going to have to do, convert your central angle to a radian, multiply it by the radius, slap a pi next to it. Okay? Radius will be given to you. The radius of the circle. What's that? Yeah. Yeah, that's the theta. That's what, remember we had, when things were written in theta, they're talking about radians. So the example I want to show you on this one, I'll go back to the area part here in a second. Show it very well at all. I want to find the arc length that has a central angle of 60 degrees and a radius of 9. I want to do the arc length first, and then we'll go back. We'll go back and talk about how you find the area. So remember, arc length is equal to theta times the radius. Well, since I'm given degrees, I have to convert that. So theta is equal to your angle over 180 times pi. So it's 60 over 180 times pi. You get pi over 3. Okay? So now, arc length is going to equal pi over 3 times 9. Okay.
So, like, 60, did you really have to show that, or you could say 60, just say it as pi over 3?
That's fine. If you knew that, yeah, because, yeah, yep. Because sometimes they'll give you 42 degrees. That's all. That's why I'm just walking it through. All right, yeah. If you know that's pi over 3 right away, go for it. Write it down. Be done with it. But sometimes they're going to give you, 100 degrees. Something that doesn't wind up on the unit circle. You just have to simplify your fraction. Divide it out your calculator, hit math, enter, enter, and it does it for you. So now you wind up with your final answer is 3 pi. There's your arc length. 9 goes into 3 how many times? 3 goes into 9 how many times? It's all about fractions. Okay? Like I said, arc length in terms of radians, easy. All right, well, let's look at how you find the area of a circle then. And when you find the area of a circle, it's no longer just pi r squared. It's going to be 1/2 the area of our circle. It's going to be 1/2, oops, so I know how to write, 1/2 r squared times theta. Once again, theta is going to be written in terms of radians. So when I go back to that last example I had here, if I want to find the area, my angle was 60 radius was 9. So the area is going to be 1/2 of the radius squared times theta. So the 81 over 2 times pi over 3. What's 9 squared? And then you just multiply out and simplify. Did you get me simplify? Just another one. And that's the area of our sector. Did I say circle? I meant sector. I'm sorry. I just realized, like, why did it equal 81 pi r squared? Or, I meant area of a sector. That's another new term we're going to worry about on Monday. We are not cross-multiplying. You only cross-multiply when you have an equal sign. We're multiplying straight across. Cross-multiply is only when fraction equal fraction. This is fraction times fraction. Goes straight across. I'm simplifying diagonal. Theta was pi over 3. I didn't realize I said circle. I meant sector. I'm sorry. Area of the sector. Okay? It happens. Come on. Okay? So that's how you find the area of the sector. Remember, the area of the sector is like the chunk, it's the piece of pie that you cut out of the circle. It's the whole part with the curve. Okay? These are very simple formulas, I hope. You agree? A little bit easier than the other stuff we did at the beginning of the year, semester, or chapter. All right, well, let's look at the other formulas I wanted to talk about today. Anytime we're done. Guys, worry about holding.
If you're not crossing, why did you cross out 3 and
I'm simplifying diagonally. I'm not cross-multiplying anything. 3 goes into 81 27 times. I simplified it. That's it.
So could you also have just 27?
Okay, here's what you do. Because obviously, here's one thing I want you guys to remember. None of you were taught how to work with fractions, unfortunately. Here's what you do. You all have a brick on your desk, on a calculator. If you had a brick on top of your calculator, it would be bad, but take said calculator out. If you have no clue what you're doing, here's what you're going to do.
81 over 6 is the same thing as 27 over 1. So you just like
Here's what you're going to do. When you do these types of problems, you are multiplying straight across. You go 81 times 1, divided by, parentheses, 2 times 3. In your calculator, 81 times 1. Enter. Divided by, parentheses, 2 times 3. Enter. I get 13.5. All right. Math. Enter, enter. Slap a pi next to it. You're done. Calculator do the work for you. Unfortunately, you guys were not shown how to do that yesterday. Calculator probably won't simplify fractions. That sucks. Why'd you drop it?
I didn't drop it. I'm probably going to drop it.
Merry Christmas. Next formula. How to find the area of a triangle. Using signs. In order to figure out the area of a triangle, we all remember, whenever you wanted to find the area of a triangle, you guys all knew it was 1/2 base times height. Well, not always you're going to be able to figure out where your bases and your heights and stuff are. Sometimes you're just going to be given values. When that's the case, you have something like this. The area of any triangle is going to be equal to 1/2 the product of the lengths of the two sides, and then their included angle. So you want to think about this as being a side angle side setup. This is always going to be a side angle side setup. It's going to be two sides and the included angle. Okay? When you know that information, should you be in degrees or radians? Okay? Correct. So it's just a matter of using one of those setups. These formulas are all the same. Remember, your best bet when you're doing these, draw your diagram and figure out what you're going to do. Okay? So what we're looking at here is the area of a triangle. It's going to be 1/2 the sum of the two sides and then the sine of the included angle. That's the easiest way to look at it. It's a side angle side setup. Okay? It's a side angle side setup. Let me get the value. I'll put the formula up at the same time here. Let me just get the values real quick. So, oops. I'm looking at this example here. I have included angle and two sides. Do you agree?
Yes.
So it winds up being 1/2 3 times 5 times the sine of 55. In my calculator, am I going to write 1/2? 25. Just type it straight through. And you can type it straight through like that, exactly the way it's written, but make sure you are in what mode? Degrees! This is a triangle, ladies and gentlemen. Yeah, more often than not. 6.14. It's June 14th. It's Flag Day.
It's also.
It's my mom's birthday. Yes, it was, and I forgot to play you guys a pie song. Well, that's where life offers more.
Cool.
What's that?
It's like some Mr. Griffith said it's like I day or something like that. So exactly.
Yes. Remember, my answer to that is you can wish in one hand and the other, see what goes up first. A square pie? Yes. When I graduated from college, my parents made me a square pie.
Really?
Yes.
Why?
I don't know. Because I have a degree in math, and they figured that'd be funny. It was very nice of them. I think I had a piece. Yeah, it was good. All right. So, dealing with these style problems, once again, it should be fairly simple. Should not be scary. So let's just try a couple of these real quick. Let's just do 13 and 14. Try and find the areas of the triangle. Now, they're telling you that those are the two sides and the included angle right away, so it's going to be really, really easy. As long as you're in degree mode, you're going to be just fine. What?
24.59.
Do you want us to go to?
I agree. Yeah, I always go 2 decimals. That's kind of like my standard.
That's not what I.
Well, you did it wrong then.
What do you mean?
What you type in?
5 times 16 times 4 times 7.
Well, it's 127, so that'd be why.
Oh.
And then the other one. Do those. 2 sets of problems. One of the other things I'm going to suggest, we are testing on Tuesday. Yeah. Suggestion. When we come in to class on Monday, this is not going to take us very long to go over. It is not going to take us very long to go over at all. What I want you guys to also spend some good time looking at is your chapter review. Look at the chapter review in chapter 13. I do not remember what page it is. It's probably around after page 810. My best guess is 824. Thanks. Bye. And I would come to class ready to ask questions. Because I will be going back, we will talk about the quizzes on Monday. 822, I was pretty close. It's on 822. And we went, I would say 1 through 35. I would make sure you spend some time on those. I think there's one thing in here. We didn't do the Heron's formula. We don't need to. Okay. Yep. Those are really, 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 really good problems to review as well. Now, this is, the test on Tuesday is everything in chapter 13. So it's going to be the stuff you did on that quiz, as well as sines and cosines and some of these area ones. I'm not going to get too crazy. I think there's another formula for solving for area of a triangle using a little bit more of the law cosine stuff. It's so uber complicated. It's really unnecessary. So I'm not going to worry about it. I'm not going to collect it, but it would be a really, really, really good idea to look at that so we have stuff to talk about. Okay? Questions? You guys have some time today to do some work. Please do so.